Hello all, welcome to the Countingwell exam prep live session. We know that exams are around the corner and the two important factors of scoring good are revision and lot of practice. So start studying now and be proud later. Hit this exam harder than you have done before. Don't stress, do your best and forget the rest. And we are here to help you revise the concepts before it's too late. For this, stay tuned to the session and build up the confidence to face your exams. In this session, I will take you through two chapters, simple equations and algebraic expressions from class 7. Let us see some basics from the chapter simple equation. So what is basically an equation? It is nothing but a statement of an equality containing one or more variables. For example, here we can see 2x plus 3 equals to 5. This is an equation or mathematical statement involving the equality sign or the equal to sign as shown here. So here we have one variable which is x. An equation can consist of more than one variable as well. So if I say 2x plus 2y equals to 10, then that is also an equation having two variables x and y. An equation can have three variables as well. So if I say x plus y plus z equals to 5, then it is also an equation. So it should be a mathematical statement involving the equality sign. Now let us see how to form an equation from a statement and vice versa. To form an equation from the given statement, we follow the steps as given here. First, you have to identify the unknown quantity in the statement and you have to represent it with a variable. Then you have to identify the relationship between the known and the unknown quantities. And then you have to identify the terms which tells us what operations is involved. Okay. And at the last, you have to form the equation relating to the quantities. For example, if you have a statement as given here, a number increased by 13 gives minus 19. Here, what is the unknown quantity? It is a number. So as we don't know that number and it is unknown, we take it as small letter y, which is a variable. So we are representing the unknown quantity, which is a number, with a variable small y. Now we have to identify the relationship between known and unknown quantities. So what is known quantity here? It is the number minus 19. So the statement says number is increased by 13 and it gives minus 19. So what is the relation between y and minus 19? You can see one more known quantity. Which one it is? It is 13. So we have y plus 13 equals to minus 19. So here in the third step, you can see we are identifying the terms which tells us what operations are involved. Here you can see the operation addition is involved because here the keyword is increased. So whenever we say a number is increased, then we add that number to the variable. So that's why we have got an equation which is relating to these quantities. So this is an equation relating the unknown variable y and the known quantities 13 and minus 19, and the operation involved here is addition. Now let us see vice versa how we can do this. If we are given an equation, then we can form a statement using that equation. First, you have to observe the expression on either side of the equality sign. As we know, an equation consists of equality sign. We have two sides. We have left hand side and we have right hand side. So you have to observe the terms on the left hand side and the terms on the right hand side. Then you have to look for the operation used in each expression. Okay. Whatever terms we have on our LHS will be one expression and terms involved on RHS will be another expression. Then you have to identify the operation, whether the addition is used or subtraction. Then you have to form a statement for the expression on the LHS and RHS. So you can write that as statement of LHS gives statement of RHS and vice versa. For example, if we are given a mathematical statement 3p minus 7 equals to 11. Mathematical statement means we are given one equation. Here note that the variable is p, means it is an unknown quantity. The known quantities are 3, 7, 11. Okay. Now we have to write this relation between the known and unknown quantities using verbal statement. So here what we have done, we have taken 3 times of the unknown variable p and then we have subtracted 7. So the resulting will give you 11. So thrice a number is 3p, and if we take 7 less from that number, we'll get 11. So what is statement of LHS? Statement of LHS is 7 less than thrice a number. And statement of RHS is 11. So we have 7 less than thrice a number gives 11, or 7 less than thrice a number is 11. Now let us see how to solve an equation by balancing method. Okay, solving an equation means we have to find the value of unknown variable involved in that equation, such that if we substitute that variable by that value, the statement is satisfied. For example, here you can see if you put x equals to 6 in the place of x, or you substitute x equals to 6 in LHS, you will get 3 into 6, which is 18. And 18 plus 7 is 25. That's why we say x equals to 6 is the solution of the equation 3x plus 7 equals to 25. So, to solve an equation or to find the value of variable by balancing method, the same operation must be done on both sides with the same number. So just remember, same operation, same number, and on both the sides. So for example, here if you want to find the value of unknown variable x, first you have to remove this 7. So to make this 7 as 0, you have to subtract 7 from LHS. You have to do the same on RHS. So you have to subtract 7 on both sides. So we have 3x plus 7 minus 7. Since we have done minus 7 on LHS, we have to do the same on RHS. So we have 3x plus 7 minus 7. By doing so, what we are getting? The 7s are getting cancelled out. So we have 3x on LHS and 18 on RHS. So in this way, we can now divide 3. If you divide 3 on LHS, you will get x. So you have to do the same on RHS. So you are dividing 18 by 3. So you have 3x divided by 3 is x and 18 divided by 3 is 6. So x equals to 6 is the solution of the given equation 3x plus 7 equals 25 by balancing method. So in the exam, they will mention which method you should use to solve that equation. So in case of balancing, you have to perform same operation on both sides using same numbers. Next, solving an equation by transpose method. So this is one more method to solve the equation. In this method, we take a term on one side to the other side by exchanging the operation. Exchanging the operation means addition will be interchanged to subtraction while transposing, whereas multiplication will be changed to division. And if it is subtraction, then it should be interchanged to addition. Vice versa, division has to be changed to multiplication. while we are transposing a term. Now let us see what is transposing. Here, for example, we have 2x plus 8 equals to 20. So when you are transposing 8 to RHS, means you are sending 8 from LHS to RHS. Since 8 is taken or added to 2x, on RHS it will get subtracted from 20. So we have 2x equals to 12. Now we are transposing 2 to RHS. So as 2 on LHS is multiplication, is in multiplication with the unknown quantity x, it will get divided on RHS. So we have x equals to 12 divided by 2, which is 6. Okay, you can cross check if your answer is correct or not by substituting the value of x in the original equation and checking whether it is equal to the RHS, which is here 20. So these are the two methods to solve an equation. Remember, solving an equation means finding the value of unknown variable or unknown quantity in that equation. Now let us see some basics from the chapter Algebraic Expression and Identities. Let us see what is a term. A term is nothing but a combination of constants and variables combined by multiplication or division. A term can be simply a constant or a variable. So whenever I say 4, it is a constant. So this is also a term. Y is only a variable. So this is also a term. 5b square is a combination of variables and constants. So variable here is b and constant is 5. So 5b square is again a term. 4a is a term because 4 is a constant and a is a variable. They both are combined by multiplication. In case of 5b square also, they are combined by multiplication. So we have 5 into b into b. Let us see what are factors of algebraic terms. These are nothing but algebraic terms because there are involved variables along with constants. Let us see what are factors. Factors of 4by are 4b and y. Because 4b and y will exactly divide 4by. That's why they are called factors of 4by. For example, if you divide 4by by 4, you will get the answer as by. If you divide 4by by b, you will get the answer as 4y. If you divide by y, you will get the answer as 4b. Out of which the numerical factors are 4 and algebraic or literal factors are b and y. So the factors of any algebraic term can be numerical or algebraic factors. Let us see what is coefficient of any algebraic term. The coefficient is nothing but the numerical factor in a term. First of all, what will be the factors of 4ay? 4ay is nothing but an algebraic term and the factors of 4a and y, out of which 4 is a numerical factor, a and y are algebraic factors. That's why coefficient of ay is 4. So how we define coefficient? Coefficient of variables ay is 4 in the algebraic term 4ay. Also, any factor in a term is called the coefficient of the remaining part of the term. For example, here we can say coefficient of y is 4a. Okay. But generally it is a numerical factor in a term. So if you are asked to find the coefficient of 5b square, then it will be 5 because 5 is the numerical factor of that term. Let us see what are like and unlike terms. So like terms are nothing but terms having same algebraic factors or literal factors with same powers. Okay. As I said, algebraic terms have two types of factors. One is constant factors or numerical factors, and one is algebraic factor. So here you can see we have two terms, 7x square and minus x square. The numerical factors of 7x square is 7, whereas for minus x square is minus 1. And the algebraic factors for 7x square are x and x, whereas for x square is x and x. Also, they have the same power because we can see x square and x square in both the terms. So they are like terms. Similarly, you can see the two algebraic terms minus 7p square q r cube and 3p square q r cube. Here you can see the numerical factors are minus 7 and 3, whereas the unknown quantities or the variables are p, q, r, and the power of p in both the terms are same, that is 2. Power of u is 1, power of r is 3. So these two terms have same algebraic factors with same powers. That's why these two terms are like terms. But in case of unlike terms, they have different algebraic factors or having algebraic factors with different powers. So there will be two cases for the terms to be called as unlike. One is they have different algebraic factors. So here you can see it is b and here it is ay square. So the algebraic factors are different. Here we have b, here we have a and y. Okay. Or what will happen if the powers are same? So here we have x, here we have x square, the powers are not same. If they are same, they are called like terms, but here they are not same, so they are unlike terms. What are the numerical terms here? For 3b and 2ay square, they are 3 for 3b, and for 2ay square it is 2. Let us see operations on terms, addition of like terms. While we are adding like terms, you have to add the numerical coefficients of the given like terms. For example, 5b and 7b. Here, what are the numerical coefficients? Numerical coefficients are 5 and 7. Whereas algebraic coefficients are b and b for both the terms. You can see that b is common factor for both the terms. So we take it as ones and you'll add 5 and 7. So you'll have 12. Note that we cannot add unlike terms. Same goes for the subtraction of like terms. You have to subtract the numerical coefficients of the given like terms. So here we are doing 15 minus 7. So we have 8. And the coefficient, algebraic coefficient is same, which is b. We cannot subtract two unlike terms. What is algebraic expression? It is nothing but formed using variables and constants using different operations like addition, subtraction, and expressions are made up of terms using different operations. So here you can see 2x plus 2y is an algebraic expression because it is formed by variables x, y, and a, and different operations are included. Here you can see addition operation. So basically when we add or subtract algebraic terms, then we get algebraic expression. Here we can see 9ay square plus 6 is an algebraic expression because it is formed by variables a and y and constants 9 and 6, and they are added like this. Similarly, 2k plus 4m is an algebraic expression with variables k and m. Let us see what are types of expressions. Expressions can be monomials, binomials, trinomials, polynomials. So monomial is nothing but expression having only one term. So that one term can be a single variable, can be a single constant, or a combination of both, but it should be the combination of a variable and a variable and a constant using multiplication. So here you can see x. X is nothing but x into 1. 2 is nothing but 2 into 1. And it is minus 3 into y square. So these are algebraic expressions having one term. A binomial is nothing but it is an algebraic expression with two unlike terms. So there should be two unlike terms, which is very important, because if two terms are like terms, then we can add them or subtract them and it will get converted into monomial again. So we'll get only one term in that algebraic expression. So it is important that the two terms should be unlike. So t plus 1 is a binomial because it is a combination of variable and a constant by operation plus. Then we have 2 minus y square. So 2 is a constant, y is a variable, and both are unlike, and they are combined using the operation minus sign. Similarly, minus 3y square plus y. It is a binomial because it has two terms, minus 3y square and y. Note that these two terms are unlike because they have different powers of the variable y. Again, trinomial is an algebraic expression having three unlike terms. So we can have t cube plus t plus 1 or y cube minus y square plus 2y minus 3x square plus x minus 5. These three are trinomial because there are three unlike terms. Here you can see it is an algebraic expression in variable t having different powers of t. So they are unlike terms. Similarly, for the algebraic expression in variable y, all the terms of y have different powers of y. And same for the third example, minus 3x square plus x minus 5. What is a polynomial? It is an algebraic expression with one or more terms. So polynomial should have at least one term or more than one. So it can be two terms or three terms or four terms and so on. Let us see operations of algebraic expressions. Addition of algebraic expression when we are having like terms in the expression. So if you want to add 3b plus 2ay square and 7b plus 2y, just you have to write these two expressions using the addition. Then you have to add the like terms. So like terms are the terms having same variable with same powers. So here you can see 3b and 7b have same variable b with same power 1. So we add 3b and 7b, which is 10b because we are adding the numerical coefficients and retaining the variable b. Then we add 2ay square plus 2y. But these are not like terms, so we have to keep it as it is. So by adding these two algebraic expressions, we get the answer as 10b plus 2ay square plus 2y. Same for the subtraction, we have to subtract the like terms and retain the unlike terms as it is because we cannot subtract unlike terms. So here we have 2b plus 2ay square from 7b plus 2y. So you are subtracting 2b plus 2ay square from 7b plus 2y. So after opening the bracket, we'll have minus 2b minus 2ay square. Note that 7b and 2b are the like terms. So we are subtracting the numerical coefficients. 7 minus 2, we have 5b. And the other two terms should remain as it is. So we have 5b plus 2y minus 2ay square. Let us see value of algebraic expressions. Finding the value of algebraic expression by substituting the value of the variable. So here we have value of algebraic expression given the value of a variable. For example, if you want to find the value of a minus 7 for a equals to 5, then what we are going to do? We are going to substitute a as 5. And so we have 5 into 5, 25 minus 7 equals to 18. Okay. Let us see some tricks involved for these two chapters. Remember, while identifying algebraic expression and algebraic equation. So algebraic expression is a combination of algebraic terms and constants combined using mathematical operations like addition, subtraction, multiplication, and division. Whereas algebraic equation is formed using algebraic expression, constants with equality sign. So there should be an equality sign. So here, for example, we have 4a plus 7b as algebraic expression in two variables a and b, where the constants are the numerical coefficients. We have 4 and 5. There is no constant term. Or 2x plus c, the numerical coefficient for 2x is 2, and the variables involved are x and c. Then we have algebraic equation. It is an equation with equality sign. So you can see 4a plus 5b. This is an algebraic expression. We have taken equality sign with equal to some constant here. So it has become algebraic equation now. And here we have 2y plus 4y equals to 34. Note that this is also an algebraic equation because we have used here equality sign. Also, whenever an algebraic equation is given, we are finding the value of a known variable satisfying that equation. But whenever we are asked to find the value of algebraic expression, we are always given the value of the variable that has to be put in the expression, and the value of that expression has to be found out. Also, you have to remember this while you are forming algebraic equations or expressions from a verbal statement. So whenever in the statement the keywords comes as equals or equals to or is or amounts or represents, that time you have to use the operation equality sign. And in the verbal expression, if you have sum of, added to, increased by, plus, or total, you have to use the operation addition. Whereas when the words comes like subtracted from, difference of, less than or minus, you have to use the operation subtraction. If the keywords comes as product of, multiplied by, or times, you have to use multiplication sign there. If it is quotient of, divided by, or over, the operation used should be division. Also, you have to remember this whenever you are solving an equation by balancing method. You have to perform the same operation on both sides with same number, and both sides of which sign? Equality sign or equal to sign. For example, here you have 5x minus 6 equals to 9. What you have to do? You have to find the value of x satisfying this equation. So first you have to nullify this, or you have to make minus 6 as 0. So if you add 6 to minus 6, you will get 0. That's why we'll add 6 to both the sides. So that is what we are doing in balancing method. So we will get 6 cancel out. We have 5x equals to 15. Now we want to find the value of x. So 5 is multiplied to x here. So in order to make it as only 1x or x, you have to divide LHS by 5. So we have to do same on RHS. You have to divide 5 on both the sides. So you have 5x divided by 5 equals to 15 divided by 5. So we have x equals to 3. So this is nothing but the balancing method. We are balancing both the sides in every step by doing the same operation on both sides with same number. Okay. While transpose method, the operation changes to its inverse. That means addition will change to subtraction. Subtraction will change to addition. Multiplication will change to division, whereas division will change to multiplication. So the interchanging will be from addition to subtraction, subtraction to addition, multiplication to division, division to multiplication. For example, if you want to solve this equation by transpose method, we'll first transpose 2 to RHS. So minus 2 will become plus 2 on RHS, we'll get 8. Then as 4 is multiplied to x, we are going to divide it by 8 on RHS. So we'll get x equals to 2. Verification of answer after finding the solution of any equation is very important. So whether you use transpose method or balancing method, you should resubstitute the value so obtained in the equation and check. For example, suppose you have solved this equation. Okay, so let us solve this equation. Okay, here which method is used? Here we are using transpose method because we are transposing 2x on LHS. So 2x will become minus 2x. So we have 4x minus 2x equals to 6. So we have 2x equals to 6. Again transposing 2 to RHS, multiplication will go to division. So we have x equals to 3. Now we have to check whether x equals to 3 is the solution of this equation or not. For that, we will substitute that value in the equation. So let us substitute x equals to 3 in the equation. So we have 4x equals to 6 plus 2x. We'll substitute x wherever we will find x. We know that 4x is nothing but 4 into x. So we have 4 into 3 equal to 6 plus 2 into 3. So we have 12 equals to 6 plus 6. That's why we have verified the answer. If you're not getting these two answers equal, then your answer is not correct. Also, while constructing an equation, you have to perform the same operation on both the sides of equality sign. Let us see some tips to identify like terms in case of algebraic expression. Remember that while you are identifying like terms, you have to look for terms having the same algebraic factors or literal factors with same powers. So just remember, same algebraic factors, same powers. So here algebraic factors are what? X, Y. Okay, in each of this. So in first term, algebraic factors x, x, y, here x, y, but here we have y cube. In case of second set of terms, we have x, y. Here we have x, y. Here we have only y. Okay. If we take all these algebraic terms together, so in all we get 6 terms. So among these 6 terms, if you want to identify the like terms, just look for the same algebraic factors. So which are the terms having same algebraic variables? X, y. We have x, y for this term. Okay, we have x, y for this term. We have x, y for this term. Note that the powers are also same, x to the power 1. Here also x to the power 1, y to the power 1. So these two are like terms. Similarly, here we have x to the power 2. Here also we have x to the power 2. And here we have y to the power 1. So these two are like terms. And these two are not like terms. So these, except these two, the pairs are 2xy and 3y, 5x square y and 3x square y. So the advantage is you can only add the like terms and not the unlike terms. Let us see simplification of algebraic expressions. While simplification, you have to bring the like terms together and then add or subtract. So as we saw how to identify the like terms, you have to group the like terms and do the operation. So bringing the like terms, we have 5x square y minus 3x square y plus xy minus xy and 5y plus 4y. You have to group the terms, like terms together using the signs of that terms. So here you can see you have minus 2xy. So you have to take minus 2xy with xy. So don't forget to take this minus sign also along with 2xy. Then you have to add or subtract. So here you can see 5 minus 3 is 2. 1xy, if no coefficient is given, so it is 1. 1 minus 2 is minus 1, so we have minus xy. Then we have 5y plus 4y, which is 9y. Let us see what are some common mistakes that a student can do when he or she is solving by the balancing method. So to maintain the balance of the equation, as I told you, have to add, subtract, multiply, divide by same number on both the sides. For example, to solve the equation minus x plus 2 equals to 8. So we have to subtract 2 from LHS and RHS. So here we can do plus 2 minus 2. So this will get cancelled out. Here you can see in the second method, the child has only done subtraction on the LHS, but no action taken on RHS. So this is the wrong way. Whereas to solve an equation by transpose method, if we are transposing constant terms from one side to other, we have only the variable on one side and the constant on the other side. Till this, we have to do that process. So transposing constant terms from one side to another side until we have variables on one side and constants on the other side. And while transposing, there is an interchange of the operation. For example, if plus 3 is transposed to opposite side, it will become minus 3. If minus 5 is transposed, it will become plus 5 to the opposite side. So if it is minus 3 on LHS, it will become 3 on RHS. Or if it is minus 3 on RHS, it will become plus 3 on LHS. So when one number is multiplied on one side, it becomes divided when transposed to the other side. Similarly, if it is on multiplication with variable on one side, it will be transposed to other side by division. Let us see some examples. Here you can see y plus 7 equals to 9. We are transposing 7 to RHS because we want constants on one side and variables on one side. So here we have y equals to 9 minus 7. Note that here it is plus 7 on LHS. So on RHS it will become minus. So the first way is the correct way to do. Let us see second example. Here we are transposing minus 8 to RHS. So minus 8 will become plus 8 and not minus. Let us see the third example. Here we are transposing b, which is in multiplication with 5 to RHS. So we have minus 20 divided by 5, not minus 20 multiplied by 5. So this method, this way is the correct way. In fourth example, we can see 6 is divided by x, and on RHS it will get multiplied to 5. So this is the correct way. Let us see from the chapter Algebraic Expression and Identities. Each constant is an algebraic expression, more specifically a monomial. So minus 3 is a constant. It is a monomial because it can be written as minus x to the power 0. Since x to the power 0 is 1, so minus 3 is an algebraic expression. And since it is only one term, it is a monomial. So no matter what is the number, you can take 10, 11, 3, minus 2, plus 2, all are constants. And more specifically a monomial. Identifying terms of an expression. Whenever you are writing terms of an algebraic expression, you have to copy the sign also. So whenever you're talking about the terms of the algebraic expression, x cube plus 2x square minus 5x minus 4, the terms should be taken along with sign. So it will be x cube plus 2x square minus 5x and minus 4. So there are how many terms? There are 4 terms of the expression. So here you can see minus 4 is a constant term. Minus 5x is also a term. 2x square is a term and x cube is a term. If no number is written with combination of variable, then the numerical coefficient of the term is always 1. So if you have an algebraic term xy square, you cannot see any numerical coefficient like 2, 3, 10, 11, 12, etc. It is hidden, or we can say it is nothing but 1. So the numerical coefficient of the term xy square is 1. Also, while adding or subtracting terms with variables having exponents greater than 1, you should only add the coefficients. Do not add or subtract the exponents. For example, if you want to add 4p cube and 7p cube, then just add the numerical coefficient which is 4 and 7. You no need to add 3 and 3, the powers of p, to get and write it as 6. So p cube should be taken common and you have to add numerical coefficients 4 and 7. Okay, let us see some exam tips for these two chapters. First is you have to practice a variety of questions from NCERT books and exemplar as well. You can try from other textbooks and from previous year question papers. You have to note down all the definitions and properties separately and avoid calculation mistakes while finding the value of the expression or solving any equation, particularly when you are using transpose method or balancing method to find the solution of any equation. Next is you have to read the question carefully and understand it properly. And at the last, you have to check whether you have answered all the questions and parts of the questions. I hope this session was helpful, and if you want to quickly revise the concepts, practice some extra sums and also take a quick test, then Countingwell exam prep kit is here. It lets you quickly glance through the major concepts of your chapter. You can also glance through the solved examples, practice questions, and chapter assessments. You will also understand the tips and tricks, common errors that you make, etc. Over 75,000 students trust Countingwell for their math learning, and even without the exam prep kit, they can learn every day on the app by diving deep into every chapter. You can download the app from App Store or Play Store. Also, stay connected to our channel Countingwell and learn more tricks and tips and ways to avoid common mistakes. We will be revising the chapter Understanding Elementary Shapes from class 6 in our next live session tomorrow on 18 February at 6:30 p.m. Well, See you in the next session. Until then, keep learning and keep growing. Thank you.